Hello and welcome to the Crossveil OpenShift Operational Assessment Demo. I'm John, representing our managed OpenShift platform engineering team, also known as PodOps. Typically, we onboard clusters that exhibit issues and suboptimal practices, often without our customers being aware of them. Let's see how Crossveil can help here. First, we are going to take a quick overview of an OpenShift cluster. As you can see, the cluster is fully functional. Let's take a look at some projects and see if there are any issues that need attention. Observe, this project currently hosts a healthy pod, which is excellent news. Nevertheless, we should further investigate to uncover any underlying issues. Doing this manually can take a while, so we are going to automate this procedure. For that purpose, we need the Crossveil catalog source, where our assessment operator is included. A catalog source is a custom resource definition. To do that, we need to add a new catalog source instance with Crossveil's operator information. So we fill in the fields in the web console and then click on Create. We observe the catalog source instance seamlessly integrated and prominently displayed among the other catalog sources. After a couple seconds, we are able to find a new catalog that will be shown in the Operator Hub tab under the Crossveil name, and look, there it is. Let's install it. We can leave all the configuration as default, so we click on Install, and the operator is now being installed. Once finished, we are now able to see the operator in the Installed Operators tab, and now we can launch the Crossveil assessment. Clicking on Create Assessment, a YAML editor window will appear. There we are going to configure the parameters needed to ensure the assessment runs correctly, like the namespace where we want the assessment pod to be placed. In this case, we already have created a namespace called Assessment Test. We also add the environment variables to be used by the pod. This is going to create an assessment object in the cluster, as we can see on the screen. Clicking on the object, we can navigate through its configuration, and on the Resources tab, we will start seeing the related objects to make the assessment run. And there we go. After a few minutes, the result is sent to the Crossveil team, and we start to analyze your case. This document contains information about your cluster. Now let's take a look at the checks performed in this cluster. As you can see, the OpenShift version is not supported. It's risky to be out of support, especially during an outage. The etcd and storage from the nodes does not meet recommendation, and this could be a big issue with application sizing. Also, the allocated resources for Kubernetes are insufficient, potentially leading to node downtime. There is a problem with etcd. This is a significant stability concern, as the absence of an odd number of instances leads to an unhealthy status. Regarding storage, it's evident that logging and monitoring components lack allocated storage, and there are also orphaned volumes present. There are some warnings concerning how objects are handled in the cluster, such as the absence of HPA settings, pods experiencing multiple restarts, and the lack of network policies. Lastly, there's an issue with setting the requested resources versus the actual usage of objects in the cluster. The Crossveil assessment also extracts the current metrics of the cluster, which play a vital role for analyzing the capacity of the cluster. We check the current status of the nodes to ensure there are no reported issues. Although all nodes indicated a healthy status in this case, we've already identified concerns with the loads. We also get a summary of the current namespaces deployed in the cluster. Cluster operators are the backbone of OpenShift. We've confirmed an issue with etcd, as its operator is degraded. Finally, we review users, groups, and service accounts with cluster admin privileges. In this instance, we didn't identify any, which could be indicative of the cluster being managed with kubeadmin, a practice that is not recommended. Hi Alex, we have problems, but what can we do?
Good thing you have hired the Crossveil PodOps team. We will fix everything. Let's get to work. Initially, we'll examine the etcd status, as it's the most critical issue. Upon reviewing the pods, we notice that an etcd pod is missing. This pod should be located on master 0, but is currently absent. As etcd is a static pod, we have to go into the node. To do that, we take the name of this node, and through the web console, we can open a terminal into the node. Let's take a look at the manifests folder in the path, etc Kubernetes manifests. We see in the manifests folder that the file is not there. A very common human mistake due to lack of experience is to place this in the Kubernetes folder, not in the manifests folder. Look, here it is. This is the file we need. We move the manifest to the correct folder. We double-check that the manifest file is now in the correct folder. Now we have to check if the etcd pod is now up and running, and yeah, it is. We also see that somebody left the node cordoned, so we proceed to uncordon it, as this can cause a problem with pod placement. Now the node is going to be schedulable. Looks like this problem is solved. Currently, the method adopted for allocating reserved resources specifically for the kubelet operation significantly diverges from the established recommendations and best practices that have been proposed. Following best practices laid out by Red Hat, we need to transition the kubelet configuration from its previous state of a static reservation to a more dynamic and efficient system of an automatic reservation. This is done through the kubelet config custom resource definition. Here, we set up an automatic reservation, allowing OpenShift to tailor the reservation based on what's needed for each worker node. After a few seconds, the nodes are systematically restarted, ensuring that now each one of them has the recommended reservation for kubelet's optimal operation. Initially, Prometheus operates without storage settings, so let's configure a volume with 40 GB, which should suffice. After restarting the pod, Prometheus will utilize storage, ensuring that no metrics are lost in the event of pod restarts. We see there is a PV not attached to anything, so let's check its parameters. To use this volume, we need to create a claim to bind the PV. Checking again the volume, we see the volume is now bound. As observed, it's perfectly accepting the past configuration. In this step, we're going to create a pod that has been specifically designed to utilize this particular volume effectively, and we see the pod started perfectly. The current configuration of the instances does not align with the specifications recommended by Red Hat. In particular, the CPU, memory capacity, and storage space are insufficient to meet the necessary requirements for optimal performance and reliability. So in this case, we need to modify the mission pool to set the correct instance type and storage. After some time, the nodes are rebooted, and we observe that the storage now meets the requirements. Additionally, the instance type has been upgraded to one with larger memory capacity. Well, my shift is over, but the cluster is going to be perfect very soon. Here is my colleague Mario.
Hi, Alex. We are a 24/7 team, so we work continuously to deliver Crossveil PodOps excellence, even when our clients are sleeping. To fix the issues regarding overcommitment, we need extra tools. These tools have been developed by Crossveil and are deployed using GitOps with Argo CD. From this tool, we deploy Grafana to have a graphical overview of the cluster with our custom dashboards, and we also have our own monitoring report where we can see the resources used by any object in the cluster. We need the OpenShift GitOps operator installed and Argo CD instance created for UI access. In the UI, we are going to deploy the Grafana application by leveraging the capabilities of Argo CD GitOps. This application is meticulously designed and deployed by the dedicated PodOps team at Crossveil. Its primary function is to continuously monitor the cluster, ensuring optimal performance. More importantly, it has the advanced ability to detect and alert the team about the early signs of any potential issues that might arise, thus safeguarding our systems from unforeseen challenges. Once Argo CD successfully deploys all the necessary objects into the environment, we are then granted the ability to seamlessly access Grafana for our monitoring needs. Grafana can help improve the deployed apps with end-user dashboards, and we also have dashboards for admins, where they can see a global overview of the cluster health and performance. The admins also use a dashboard which displays information based on the node type, where we can view metrics depending on the node type we are debugging. Here, we can find custom gauges with the instant resource consumption and custom graphs, visualizing how many objects have been scheduled there and what the node performance was for a time range specified. This provides us with more information for root cause analysis purposes. We can also observe the consumption of projects to identify potential issues. To fix the overcommitment issue, We use our deployment checker tool to analyze the deployment resources in the cluster. The results show that there are 2 deployments overcommitting, so let's check this deployment. We observe that the deployment configuration has significant resources defined, despite the minimal consumption indicated in our report. In our process, we systematically update the values within the deployment configuration to the most finely tuned ones available. Following this, upon initiating a restart of the pod, it seamlessly adopts the updated correct values, ensuring optimal performance. We see in Grafana how the requested resources are lowered and are closer to the actual usage. We do the same in the other DC. And we launch a new report where we can see both are now in good shape. Problems solved. Hi John, all the problems reported are now fixed.
Wow Mario, the Crossvale PodOps team is amazing, you made it in less than 24 hours. Let's run a new report to confirm everything is fine now. With all this fixed, we launched a new assessment to validate everything is optimal, and here we have the latest results of the cluster. As shown, all the tests are green now. The cluster is up to date, it contains the recommended resources and the recommended reservation for kubelet defined by Red Hat, guaranteeing cluster stability. etcd is fine again, the monitoring tools have persistent storage, recommended practices have been implemented, and the overcommitment issue has been improved to have a better resource utilization, making a better cluster. Now we can say OpenShift is running optimal. Following the assessment document, we can now confirm that all cluster operators are functioning optimally, as none of them are degraded and all are indicated as green. Therefore, removing the potential stability issues, an admin group has been created with admin users. So, the temporal kube admin can be disabled. Now you understand how Crossvale initiates the process of optimizing your cluster. The key to sustained optimal performance isn't just an assessment, it's ongoing dedicated oversight with dynamic workload tuning. This ensures that your clusters maintain peak performance, even amidst changing workloads and demand. My name is John, representing Crossvale's managed OpenShift platform engineering team. PodOps is the best way to achieve OpenShift workload excellence. Everything an enterprise would need to be container competent, starting at $14.99 an hour, including build Red Hat subscriptions, operationalization, 24/7 PodOps oversight. Find us at crossvale.com and see how we can make a difference.